So welcome everyone, glad that you all came. I'm happy to welcome you to the artistic Spring Data Neo4j with Spring Boot and Van Gogh. I want to thank Lorenzo, first of all, for doing all the hard work, for putting it all together, creating the application, finding the data, and coming up with the idea in the first place. Just to introduce ourselves, my name is Michael Hunger. I'm developer evangelist with Neo4j. I've been working with the company since 2011. I'm also the project lead of Spring Data Neo4j, so have been with the project from the beginning. And I just can't help myself helping people either by supporting them, by writing, by talking, by presenting, and so on. So if you have any questions, then feel free to ask any questions.
Hi all. My name is Lorenzo Speranzoni. I'm from Venice, Italy. I'm the founder and CEO of a company called Larus Business Automation. We're specialized in building applications based on the Spring platform, especially for banking, insurance, and service companies. As we approached the NO-SQL landscape, we immediately understood that graph database has great potentiality. And this year, we have become the first Neo4j solution partner for the Italian market. I recently also started to support Mikhail in improving the Spring Data Neo4j component. And finally, I love art at all, so the slides will be so colorful.
Yeah, he's the artist who created all these beautiful slides, so you have to thank him for that.
I want to introduce the case study that we will use during this talk. It was more or less the end of last year when I started to write a series of posts on my blog about an application that could tell us the story about the life of a famous painter named Vincent Van Gogh. He traveled from the Netherlands, his native land, to the south of France to die suicide in the countryside of Paris in a small town called Auvers-sur-Oise when he was only 37. His journey was a continuous research for light, color, and landscape for his painting. By modeling his journey, this case study wants to demonstrate the potential of a graph database to provide new insights in art and culture. Okay, let's go back to something more related to the Spring One conference. I actually wanted to provide you some information on what we intend about NO-SQL, which stands for Not Only SQL. It was November 2011 when Martin Fowler, chief scientist at ThoughtWorks, has introduced the concept of polyglot persistence. He intended to say, even up today, a relational database should no longer be considered the one and only option that we could use to persist customer data. In fact, as you can see on the next slide, we have at least 4 NoSQL categories with many different technologies such as Mongo, Cassandra, Redis. We can count on. Today, we want to talk about graph databases. We will focus on that.
Yeah, so graph databases are really interesting because if you look at the real world, there's no piece of information that's disconnected from each other. Everything is connected to something else. So people are connected to other people, to their companies they work at, to their families, to things they like, things they buy, music they listen to. And again, the products are connected to categories, for instance, to prices, to reviews, and so on. There are also history, there are events, there's in science, there are a lot of connected data sets, and so on. So that means in the real world, connections rule. The problem is that most databases really don't care about connections between entities. So if we look at NoSQL databases, what they mostly do is to just store foreign key or key identifiers in entities or documents that point to another entity or document. But if you want to kind of see what makes up your domain, what is kind of the essence of your connected domain, then you have to kind of query it one by one. So that's a problem with most of the NoSQL databases. The other funny thing is that actually relational databases, where is it? Also lack relationships because despite the name, it's more about relational algebra than the relationships themselves. So if you look at a relational database, the only thing that kind of puts a notion of connectedness in there is a foreign key constraint, which you immediately have to drop when you have an optional relationship. So, and the other thing that you all probably have experienced in a relational database is then when you really want to leverage connection between tables, you have a query with a lot of joins because you have a complex domain that you want to query in a kind of extensive way, then it immediately slows down because it has to compute all the connections at query time. So all the databases we had at hand have a really hard time dealing with a rich connected domain. And that's why graph databases take a completely different approach. They embrace relationships really as a first-level citizen in their data. So in a graph database, a relationship really has a data structure, a data record in a database. Graph databases allow you to take the rich domains from the real world that you can either see in your domain, that you can draw on a whiteboard, that you can discuss with a colleague, that you want to explore, and put them kind of one-to-one into your database without losing any information, without losing any fidelity. So they really allow you to put all this richness into your database and then leverage that to run complex queries on top of this to make quickly make business decisions that are affected by that. In general, graph databases are NoSQL databases. So as Martin puts it, NoSQL databases are open source. They are scalable. Most of them are also schema-free. So graph databases are also schema-free. So you don't have to set up a schema for all your kind of heterogeneous data that you have. And, but unlike the other NoSQL databases, graph databases are transactional. The difference comes from the notion that graph databases have a really fine-grained data model, which is closer to the relational model in kind of its granularity. And so you need to have some kind of change scope. When you do a change operation, you don't want to have like only 1/3 of your change operation to be done because you don't have any scope for that. And so transactions help us to have kind of this consistent update and change operation, also visibility. So all the asset guarantees are provided as well within a graph database. As I already mentioned, graph databases provide fast joins. And actually, they do a really cheap trick for doing that. So what a graph database does, it prematerializes relationships at insertion time. So instead of computing them every time you query the database, they just compute them once at insertion time, store them in a database, and whenever you want to see any kind of connection between two entities, it just takes the record that is already there and has a constant time to run your queries. And so with these fast join operations, you can also run really complex queries in a graph database. So you can have query with, I don't know, 12, 15, 20 joins in your query running in real time, which is really nice for web applications, for instance, that want to provide something like routing information or recommendations or impact analysis or other kinds of interesting use cases. Coming to use cases, there are some people that say graph databases are really important, and here are some graphs that are interesting. The social graph, everyone knows it. I don't want to talk about it a lot. The intent graph, so what do people want to do? What kind of behavior can we observe in people? And that's positive behavior, but also negative behavior. So for instance, fraud detection also is based on observing fraudulent behavior in people's activities. Consumption graph, of course, all the recommendation stuff. Interest is what Twitter works on, and the mobile graph is everything that telecommunication companies work on, network management, management of Internet of Things, all the connected devices, and so on. So actually, there are a lot of interesting domains. So when we started with Neo4j, we had like a handful or so ideas of what people would use a graph database for. Social was kind of the predominant one, and a few others. But then our users and customers surprised us all the time, because every time they come up with, I want to use Neo4j for this, then we say, OK, we haven't thought about that, but it's a cool idea. Let's try that. So in finance, it's, for instance, fraud detection, account management, portfolio management. In energy, it's, for instance, flow optimization. So if I have an energy distribution network, I want to optimize that, then I can use a graph for that. Manufacturing and logistics is, for instance, routing, high-performance routing. So if I have, for instance, a logistics company that routes 2 million packages per day, then it can use a graph database to do that in a large country. In retail, it's of course recommendations, but also other aspects like, for instance, catalog management. Telecommunication companies use graph databases for network management, impact analytics, and optimizations. And there are many more. So for instance, in HR, we see a lot of job search companies, for instance, using graph databases to give their users a much better result in getting a good new job. So Forrester had also something to say. They think that many people will use graph databases. Let's hope for that. What is a graph? In general, it's really a simple data structure. It's a data structure out of connected entities. So what we have is something we call nodes. Usually in your object model, you'd see these as objects or types or as entities in your entity relationship diagram. And these nodes are connected with relationships. And the relationships are really an important aspect in a graph database. And that's more or less what a graph looks like. And in general, there are several graph models that graph databases support. So one is the most popular one is the property graph model. There are also others like RDF-linked data. There's the hypergraph model and a few others. But interestingly, this kind of the simple model where you have just nodes, relationships, and properties on nodes and relationships, which is really close to the object model that everyone is kind of familiar with, is the one that people like the most because it's easy to understand, easy to use. You don't have to kind of get a knot in your brain to understand it. And so having this simple model makes it also easy to go from an object model like in your Java application or in your Spring application into the graph database and back. And that's why it was so easy for us to implement something like Spring Data Neo4j to provide the object graph mapping. If you compare a relational database that hopefully everyone knows with a graph, you have, in general, tables for entities. Like in our case, it's an artist in a city. And whenever you have a many-to-many relationship, you can't just say, OK, this table is connected with a many-to-many relationship to this other table, but you have to introduce this join table in the middle. Sometimes people also call this a dummy table, which is already a kind of a qualification what this is about. It's just a kind of a workaround because the relational database can't really deal with many-to-many relationships. And especially if you have a real business domain, you quickly see that you have many of these join tables in your application. And when you start building queries, they pop up all the time, and they kind of increase the complexity of your queries enormously, and also kind of affect the runtime. So in a graph, it looks similar but different because what we still have is the entities. So we have the artist and the cities. But the join table goes away, and instead we have these rich relationships between the artist or the nodes in the graph database. And these rich relationships help us model the data and also help us query the data really effectively.
If we choose to adopt a graph database, one question immediately arises. How do we model our domain in graph term? Well, in Neo4j offices, we like to say that Neo4j is whiteboard friendly. We mean that when we use a graph database, what we draw is exactly what we store. So let me just provide you a short example of what I'm saying. We can scratch on the whiteboard the concept that Vincent Van Gogh was born in Zundert, a city in the Netherlands, and died in Auvers-sur-Oise. And Van Gogh belongs to the art movement called post-impressionism. This example also gives me the opportunity to introduce the Neo4j browser, a fluent IDE through which we can write and run query statements against the database, and of course retrieve the data. Something like, ooh. We do some pretty app, and we create the nodes with some of those strange statements that I'm going to talk to you in a few minutes. And the graph database is emerging. So let me try to show you what happened. This is the browser of Neo4j, and we can execute one of those queries to retrieve the data. For example, just a moment, something goes wrong. Let me restart the database, as always when we have some presentation. Here I'm just restarting the server.
Okay.
So I can reload the browser and try again to execute my statement. Oh no.
Something's wrong.
Something goes wrong. Okay, let's just move on then. I will try to see what's happening. Maybe it's a rendering problem.
Yeah. So in general, it's from the beginning, from our initial model on the whiteboard, which is usually more complex than this. It's really cool that we can see exactly the same visualization, exactly the same data in the graph database, which also makes it really easy for us to take, for instance, a domain expert or a business expert and talk them through this model that we have in our database. It's much harder if you show them just a bunch of JSON documents in Mongo or just a bunch of tables, and then you want to talk to them about their domain model because they don't care about all the technical implementation. And in the graph, it makes it really easy because it still totally relates to their business domain that they're used to. So they have all the relationships, all the entities in there that they usually are used to talk about. So in general, the buy-in of a kind of business owner or product owner into using a technology like that is much better because they can't find themselves again in this model. Neo4j in general, Neo4j is a graph database. It's written in Java. We have been working on Neo4j for a while now, so it has been around for about 10 years now. It started initially as an embedded library, but then we developed a Neo4j server. We developed our own query language on top of that, and continued to improve the database itself. As I already mentioned, graph databases are transactional, so Neo4j is fully transactional as well. And so whenever you commit a data change, a data update, it's guaranteed to be persisted on disk and has the full asset properties. And Neo4j can be run in clustered mode as a master-slave replication cluster. So if you want to have high availability or failover, then you can have that too. In general, as we already mentioned, it supports the property graph model. Here we see a bit more detailed view of that. So we have, again, the artist and the cities. And we see the properties on both cities and on the artist. But you can also have properties on a node, for instance, the date when he was born or when he died. So, and as you can see, here we are talking about instances. So this is an artist kind of instance, and this is a city instance. So in a graph database, you often kind of work with examples. But in general, of course, you have like hundreds of thousands of artists and millions of cities in your database and millions of artworks, right? So it's just a really tiny part of that. As I already mentioned, Neo4j makes relationships a first-level citizen in the database. And so that's the way it achieves the scalability. So you really can have these high-performance queries on a database. OK, some quotes I don't want to go into, and I want to give
So whiteboards are great for describing graphs outside of any technology context. But when it comes to using a database, we need some other mechanisms for creating, and manipulating, and querying data. That's why Neo4j introduced CYPHER, an expressive yet compact graph database query language. Very complicated database queries can easily be expressed through CYPHER language. This allows you to focus on your domain instead of getting lost in database accesses. So let me just provide an example how CYPHER works. Well, I'm Lorenzo. I'm a person. It's a label. And I love Van Gogh, which is actually an artist. With CYPHER, queries becomes normal sounding statements, particularly when compared to relational database. We ask the database to find things like this, and the way we describe what things like this look like is to draw them using an ASCII art, as you can see downstairs. Like most query languages, also CYPHER is composed of clauses. The simplest query consists of a match clause, as we can see there, followed by a return clause. The match part is the specification by example part. We use parentheses to draw nodes, and pair of dashes and greater than, less than signs to draw relationship. For example, artist moved to a stage, and stage is in a city. Between the dashes, set off by square brackets and prefixed by a colon, we put the relationship name, moved to, in the example, in the other statement. The less than and greater than sign indicate the relationship direction. In this case, the artist moved to a stage. No, the previous one. The match clause indicates the parts of the data that we want to retrieve and should be returned to the client, while the return statement is exactly what we want to retrieve from the match part. So, for example, we can inquire the system with the statement to say, retrieve the artist, which is called Van Gogh, and all of the stages and the city where he went, and then return the artist, the stage, and the city. Of course, CYPHER comes out with a lot of other clauses that permits us to easily inquire the graph database. Neo4j has a dedicated team which is actually adding lots of interesting CYPHER statements, like the most recent one, load CSV import tool, through which we can massively import data from a CSV file into the graph database. This is the source of my use case. It's a site that contains all of the Vincent Van Gogh masterpieces. And those are some of the statements that I wrote to populate my database. The create statement is to populate the database. So, for example, I created the node artist, first name Vincent, second name William, last name Van Gogh. So I had all the attributes. Then I create the city where he was born and where he died. And then I create a link, the relation between the artist Van Gogh and the city Zundert, where he was born. The same for the city of Aix-sur-Oise, where he died. I also create another node. It is an art movement, post-impressionism, and I say that Vincent van Gogh belongs to the art movement called post-impressionism. And as we said before, we can retrieve those information by this simple query. Match, so retrieve the artist Vincent Van Gogh and the movement who belongs to, and the city which the artist is connected to. Here I haven't specified the name of the relationship because I want to retrieve both the born in relationship and the died in relationship. And then I return all of those nodes. In December 1883, Van Gogh began his journey by moving to Nooyen, the Netherlands. He lived there until 1885. So I wanted to track his trip. And to do that, I created a stage and indicated the period in which he stays there. And I linked Van Gogh by saying he moved to this stage, which is in Nooyen, the city linked to the stage. And then I tracked back all of the stages he went to. He went in Antwerp, and then he went in Paris, where he met all of the other artists like Monet and so on. Then he moved to the south of France, in Arles and Saint-Rémy-de-Provence. Then he came back to Paris, and finally he died by committed suicide in Auvers-sur-Oise in 19. And this is the query that can retrieve the Van Gogh journey. So match the artist and all of the stages and the cities where he moved to. And with those information, we can retrieve the art movement he belongs to. And then we return all of this information.
Yeah, what's interesting here is that the move to relationship is not just a single hop, but it's an arbitrary length relationship. So there could be, like in this case, 6 stages, but there could also be 40 stages or so, forming a kind of linked list, one after the other. And so with the star after the relationship type, you kind of say to the database, follow this relationship chain as long as you find relationships. And so it retrieves everything. And so you can easily imagine that whenever you have a kind of linked data structure, it's really easy to first put in a graph and then also handle with the graph. If you would do something similar with a relation database, you either would have to have many self-joins or a lot of joins within a statement, so which blows up your query without adding any insight to them. Right?
And of course, I also added the artworks he painted. I was actually interested not only in tracking the artworks he painted, but also where he painted those artworks. So for example, we can retrieve and understand where he painted his first famous artwork called The Potato Eaters with this CYPHER query. So it is, as before, the stage, the city Nooyen, where he painted the artwork, by tracking the relationship where realized. So with that statement, I say, in the stage Nooyen, Vincent van Gogh realized the potato eaters. So we have a match clause that retrieved the nodes we are interested in, and a created statement that created the relationship between those two nodes. I did for all of the artworks of Vincent van Gogh. This is an example. You can see in every stage, which is in Paris, Nooyen, Auvers-sur-Oise, and so on, there are some artworks that he painted. And of course, I also added the museums which hosts his artworks. This is the case study, the live demo that we want to show you just right now. And then I also added some socials. So for example, I told that Lorenzo likes Van Gogh and also likes the potato eater painting, and also posted something about the Van Gogh museums, which is in Holland. Then I say Lorenzo lives in Venice.
So in general, this shows us really easily how you can merge a lot of different domains in the same graph. So you have one core domain, which is kind of the artist and his life. But then you add additional domains like the paintings, the museums, which also have geospatial information like the cities as well. Then you can add social. And if you kind of take this idea and put it onto any other domain, for instance, you have a retail domain. And then suddenly you just don't have just products and product catalogs, but you have your users that bought products. So you have buying history, you have reviews, ratings, things like that. You have, for instance, the information where certain products were used or stuff, information like that. So you can actually combine a lot of orthogonal domains in the same graph. And that's also something that many people use in a kind of master data management, where you have data in like 20, 30 different databases, but you want to make decisions based on all the data. But it's kind of impossible to kind of cross-query across all the databases. So what you can do is to just put a graph database in the middle, project the data that you need to make the decisions from the different databases in this single graph, find the connection points where the actual data connects to each other, and then you can do the decision-making queries on the graph database without having to kind of do the kind of 10-year master data management effort that is always kind of doomed anyway, to merge all the databases into one, because as soon as you buy a new company or sell a part of your company, it's broken again, right? So, and having this kind of on-demand master data management for certain decision-making processes is also a good example for how you can merge a lot of different data sets into one graph, do your queries on top of that, and then you can make your decisions.
In this example, I wrote a simple CYPHER statement where I expressed the OR condition because I was interested in retrieving for that person's only two kind of relationship, likes and posted. This is what we can do, for example, with the CYPHER statement. And this is the whole graph. So we have an artist that Van Gogh met during his trip, which is represented with this color. Then we have all the masterpieces he painted, and the museums which host all of these works.
Okay, oops. So as we are on, at Spring 1, and I'm the project lead of Spring Data Neo4j, at some point, when we looked into this presentation, Lorenzo built actually an application, not just the CYPHER statements that you just saw to kind of import the data, which was his first kind of get to go with Neo4j and CYPHER. But then, of course, he wanted to have a real application that uses all the data as well. So he chose Spring Data Neo4j for doing that. And I just want to give you a quick overview of how Spring Data Neo4j works. First of all, I want to thank the Spring Data team, Christoph, Oliver, and all the others, Thomas, to build the Spring Data events release, which was released actually, which was built last week, but released officially yesterday, right? And it includes Spring Data Neo4j 3.2 GA. So you see that Spring Data Neo4j is quite an old project, so it's already at version 2. And this is because Spring Data Neo4j was the founding project of the Spring Data project, where actually Rod Johnson and Emil, my CEO, got together and wrote the first code of Spring Data Neo4j about 3.5 years ago. And then we took the code and made it actually work and run and so on. But anyway, so we have Spring Data Neo4j 3.2. What does it do? In general, it's the same like all the other Spring Data projects. It gives you a convenient way of working with a NoSQL database. You're a Spring developer, you use the POJOs to domain classes to entities. You just want to annotate them or not and be able to kind of save them and retrieve them from the database directly without any fuss. And still have the power of the graph database behind the scenes. So whenever you want to really leverage this kind of connection-centered data store, then you can go to the Neo4j levels, API levels, and have the queries that you want to run directly in the database and project the results back into your domain entities. That's the cool thing about it, that you kind of take the power of the database when you need it, but you can easily convert, for instance, query results back into your domain entities, for instance, to use them in the view layer or interact with another framework like, for instance, Spring Integration or so. It uses annotations as all the other Spring Data projects as well. It has a it has a Neo4j template, which is similar to JDBC and Mongo template to interact with Neo4j. And it's been around for a while, as we said. It's also covered in the Spring Data book that you might have heard of, and which is a really cool kind of summary of all the Spring Data projects and written by the Spring Data authors. And it builds on the same shared common infrastructure that Spring Data Commons offers. Besides the object graph mapping that we already know, it also adds or provides Spring repository support, so the interface-based repositories that you might know from Spring Data projects. They are also available for Spring Data Neo4j. The convenient Java configuration or XML configuration that you're used to from Spring Data projects is also available. Lifecycle methods, so you get events when entities are saved, deleted, and so on. And it also supports Neo4j server. And we will show that in a bit. So that's kind of everything you would expect from a Spring Data project. In general, when you choose to work with Neo4j from Java, you have a number of options. So either you could use Neo4j as an embedded library within your Java application, because that's where it started, and which is kind of still the fastest way to talk to Neo4j, because there's no network in between. It's just in process talking to Neo4j itself. You can talk to Neo4j server using the HTTP APIs, which is good when you just want to send some CYPHER queries. Actually, we wrote a JDBC driver that uses them. So you can also just use JDBC to talk to Neo4j, sending CYPHER queries and getting results. But if you want to have kind of the convenient way of mapping certain parts of your database into domain objects, then you could use object graph mapping, for instance, with Spring Data Neo4j. There are some other object graph mappers as well, or they are in development. For instance, Hibernate OGM for Neo4j. There are two mapping modes in Neo4j. Initially, when it started out, when Rod and Emil got together, they focused on an aspect-J-based mode, which kind of uses your domain entities just as kind of shallow wrappers around the nodes in the database. So every property access was kind of written through and read through directly to the database. And we still have this aspect-J-based mapping because it's, on one hand, it's pretty cool and pretty fast. On the other hand, it's a pain to set up in tooling, as you might know from aspect-J-based things. So if you got kind of beyond the hurdle of setting it up in your IDE and so on, then it works really well. But of course, it's much easier if you have not to deal with that. So we also have a mapping mode that just takes pieces of the data out of the database, copies it into your entities, and they're completely detached from the database. So you can do whatever. You can render them to JSON. You can put them in the web frameworks and so on. So in this example that we will show, we also use this simple mapping. Some words to the annotations that we support. First, there's node entity and relationship entity, which, as the name says, are used to mark certain entities or classes to be represented either as a node or as a relationship in a database. Why do we have the relationship entity? Because relationships are really kind of core entities. So you can put as many properties as on a relationship as well. And if you want to represent those in your domain as well, then you want to have a class that represents this relationship. And there are other annotations. One is, for instance, index, where you can say, OK, I want to have this field in my entity should be indexed so that I can find it quicker, or it should be a unique attribute. So I have, within this type, I want to have this attribute being the unique key. And there's an annotation called related to, which says this object reference to another entity is actually represented as a relationship. So many of these annotations you can also leave off, and then they're inferred automatically. I just wanted to list them for completeness. There are a number of repository implementations that are coming out of the box with Spring Data Neo4j. And of course, they're exposed via interfaces, as in Spring Data in general. So, and two of those are the graph repository, which kind of combines the CRUD repository and paging sorting repository from Spring Data. And for instance, the spatial repository, there are a few others as well. And the spatial repository is nice because it offers all the geospatial queries that also were used in the demo use case. And I hope that you all have looked at Spring Data in general and used Spring Data repositories, perhaps. What it does, just in a few words, you don't have to write code anymore to get DAO-like repository implementations. You just specify interfaces. And Spring Data or Spring Data Neo4j does all the hard work for you. So it implements the methods that you define. It provides you with the injected instances of these repositories. And the nice thing is, of course, you can compose repositories by adding just more interfaces to your repository declaration. So we will see an example later on. And the other thing that's really nice is that they also handle transactions for you. And they provide something that's really that comes from Rails and Grails, which are derived finder methods, where you take the method name, and from the method name, you just split it up by kind of capitalized letters, and then you can generate queries from that. So some exposed methods from the graph repository are these, like find one, find all, query, which kind of takes a CYPHER query, save, delete, and so on. There are like, I don't know, 40 methods or so exposed by the graph repository. And the spatial repository, for instance, exposes something like find within bounding box, find within distance. So you have spatial methods where you can provide shapes or circles and so on. And so that allows you to use these new primitives from Spring Data comments to search within a spatial representation in a graph. Which is actually pretty cool, because the Neo4j spatial library uses the graph itself to provide spatial access. So it, in addition to your core domain entities, it adds a two-dimensional index tree in the graph as well to exactly deal with all the search operations. So it's kind of using the graph as an indexing structure and as an access structure to, for instance, provide something like spatial support, which is a pretty neat way of doing that.
So before the final conclusions and the Q&A session, we would like to show a live demo of a Spring application running on top of a graph database Neo4j, and of course in the cloud. While we were here in the Spring One conference, we heard a lot about Spring Boot and Cloud Foundry. I decided with Michael to try and test and then to move this live demo also in the Cloud Foundry, which seems quite cool. The example wants to demonstrate how we can build a geographical search engine to look for museum hosting masterpieces by Vincent Van Gogh. So we will do some query on top of our graph database. This is the domain model we just talked about some minutes ago. We have the artist, we have the artworks, and we have the relationship artwork as an author. Then we have an official location for the artwork, which is the museum that hosts that artwork. And the museum is located in a city. It would be also interesting to track, we don't have in this example, to track when a masterpiece moves from the official location to another exposition. Because it's often happened that when you go to visit a museum and you want to see an artwork, sometimes you can't find it. So the system could tell you that the masterpiece is no more, or for the moment, in that official location, but has moved to another one. And this is a technical stack that we decided to adopt. The Spring Boot that we introduced some days ago, just to understand how easy is to bootstrap our application with no configuration by using Spring Boot. Then, of course, we have the Spring Data Neo4j component through which we can access the database. The Neo4j special plugin that allows us to execute special queries on the database. Then we have an OpenStreetMap on MapQuest just to render on the screen the map where the museums are located. And then we deploy it to the Cloud Foundry. This is an example we did just yesterday, me and Michael, to understand how Cloud Foundry works. This is the architecture, more or less the design, how we organize the software of this demo. We have, of course, a presentation logic that is implemented with the Spring MVC Then we have some RESTful services that exposes URL we can access to inquire the database through a business logic tier. And then we have the persistence logic, which is actually implemented with Spring Data Neo4j. We draw this picture to represent the fact that when we execute and run an application that uses Neo4j, we could decide to use the Neo4j graph database in an embedded mode. I mean, the graph database runs inside the same virtual machine in which the application is running. So we have a strong performance for that. This is the configuration, the dependencies that we have to add to use Spring Boot. So we have, for example, to add the Spring Boot started parent, then which is actually in the version 1.16. Then, since we have a web application, we need to add the dependencies, which is Spring Boot started web, and then we embed a Tomcat instance in which the application will run. Then we have to configure the dependencies for Spring Data Neo4j, which actually are only 2 dependencies, one for the Spring Data Neo4j, and the second one, which is only necessary for special queries, which is Neo4j special. Then we configure the main application for Spring Boot, which is the class that when we run Spring Boot starts. We add the component to scan, and we import another configuration file. Then we enable the auto configuration, so Spring Boot can manage all the work for us. The Neo4j configuration requires to specify which is the location where the repository are. This is the way you have to do it. The annotation is the enable Neo4j repositories. Then we have to set the base package. This is the package where the entity classes, the domain classes are located. And then we create a graph database factory, a new embedded database, which is located in this spot. In the live example, we focused on the third option, the object graph mapping, as the two other ones are a bit more classical. And this is an example of how we can use the annotation. So for example, this is the domain class for museums, which have a name, an address, a director, a Wikipedia page, a website. We configure this class with the annotation not entity, and we give to this class a label which is called museum with the type alias annotation. Then we also added the 2 indexes to this class. One, quite standard, which is a unique index on the property called name, and one for our geospatial queries. We have an index called museum location, which is a type point, for which we can execute geospatial queries. Then we have the relation between the museum and the artworks which are located in. We use the related to annotation. Then we have an example of how we could implement a museum repository. We just have to say that our repository has to extend the graph repository and the spatial repository that Michael told you just before. And then we can write, please notice this is an interface, not a class. You just have to define the method that you want to expose and eventually the query that you want to execute when this method is called.
And actually, it's quite interesting because if you look at it, you even don't need the query because the derived finder method that you could use. I don't know if you put in a slide for that. No? We didn't put in a slide for that. But in general, the derived finder method, like find museum by name, you could even leave off the query, and it would generate exactly the same query for you behind the scenes. And for the second query, it would the derived finder method would be something like find museum by artist artwork, and then it would also find, or artwork artist, and then it would also generate the queries behind the scenes for you.
This is an example of the geospatial search that I have implemented. So the method get museums within distance receives a longitude and a latitude and a distance in kilometers from the position we are providing. We build a circle which is in this point, and the radius is of this distance in kilometers. And then we call the method, which is exposed in the geospatial interface, find within distance. We indicate the index that I told you before. Let me just show you. We indicate the index name that we want to use to access to these information. And then we provide a circle within which we want to find museum. And we return the list of museum, so as list.class. So let me show the live demo before we move to the server extension mode. With Spring Boot, what we just have to do is start our Tomcat application by running this command, Spring Boot run. So the instance starts. Starting engine Tomcat. So started application, started artwork application, and we can move to the browser and see the live demo. This is the example that I have implemented. Let me move just a bit. So the system understands where we are. And we can test, for example, how many museums are within 1,000 kilometers from here. So we can search, and the system can respond that we have one museum that is actually located in Dallas. It is the Dallas Museum of Art. And we can ask, of course, we have all the information that are persistent inside the node, so the address, the website, the Wikipedia page, as I told you before. And we can check which Van Gogh paintings are hosted just by clicking Show Hosted Painting. We have here in Dallas 2 Van Gogh masterpieces. And we can also see a preview of those masterpieces. Then we could enlarge the search, for example, by saying 1,000 kilometers from here. Oh, we have 4 museums which host Van Gogh masterpieces. Let me just show you another painting. Then, of course, I can keep enlarging the search to discover that in the USA we have plenty of museums which are currently hosting Museum of Vincent Van Gogh. I'm not so happy because in Italy there's only one museum which is actually hosting, so I have to travel a lot. With this one, which is hosted in the Vatican museums. While Michael is a bit more luckier than me, because he has a museum in, he has a museum here in Dresden. And this is the paint, which is hosted, and so on. This is the application that I built to retrieve the artworks and show the museum which hosts the Van Gogh paintings. Then, Michael, we have the server extension version.
Yeah, so we have, we saw Spring Data Neo4j running with an embedded Neo4j instance, which provides the highest performance. And right now, Spring Data Neo4j uses Neo4j's embedded APIs, more or less, to talk to the server, to talk to the database. That's why running this kind of library over the wire is not yet the most performant way of accessing Neo4j. But there's an option that how we can use Neo4j server anyway, which is just to take the persistence layer, just the persistence logic, and convert it into a Neo4j server extension. So Neo4j server can be extended with Java code, and we can actually write GOGH'S resources within Neo4j server to expose our custom domains and protocols to our clients. So we have the code running in Neo4j server talking to the database without a network in between, so it's really fast. And we expose only the information that we want to expose. So it's a kind of focused way of providing high-performance queries and only transporting over the wire the information that we really need, and not kind of taking the whole database over the wire then just to get data out of that. And that's why in the second example, Lorenzo chose to move the Spring Data Neo4j persistence layer into a Neo4j server extension, also to be able to host it in the cloud. So there's a Neo4j hosting provider called GrapheneDB, and they offer Neo4j hosting in a number of different plans. And they also allow you to install your own custom Neo4j server extension. So you don't just get a provisioned database, but you also have the means of adding server extensions to these databases. So you can more or less do whatever within your database server as well, which is pretty cool. So this Neo4j server extension was packaged and installed in Neo4j server in the hosting solution. And then we deployed kind of the front-end part of the application into Cloud Foundry. And this talks with Spring REST client to the backend, and I think also the web page talks to with AGGREGATED, right? Or yeah, talks to the backend, and that's now hosted on Cloud Foundry. We had some problems getting started because right now Neo4j is not in the kind of service broker list of Cloud Foundry, but we are having a talk with the Cloud Foundry guys today, so we'll see what happens there. Yeah, and this was more or less why we did it. And Lorenzo wants to show us now how he actually implemented it.
When you want to move your repository tire into a server extension, you have to do some small steps. The first one is to add a file, the plugin lifecycle, and just add a class which actually configures the plugin. And this is the class. You just have to say that this class extends the Spring plugin initializer, and you have to provide the Spring objects that you want to use and you want to expose through your plugin. So for example, I added the museum repository, I added the artwork repository. Those are the classes that allows us to inquire the system and expose the JRC resources. This is an example of how we can expose as REST services, for example, /long, /lat, and distance in kilometers. And then we call the museum service get museum within distance by providing the 3 parameters. And as before, we return to the web application the museum that we retrieved. When you build a server extension, you just have to compile and you will obtain a jar that you have to copy inside the plugins directory. This is the place where you have to put your server extension. And then you have to indicate that you have a new server extension, and you have to provide a name for your extension. This is actually done by modifying the Neo4j server property files. You just have to add one line by specifying that Neo4art is the URL that exposes your Jersey resources. And of course, we could curl our server extension. So if I run this curl statement against the extended database, please look the Neo4art, which is the information that I actually configured there. So if we execute this curl, we obtain the museum, Dallas Museum of Art, which was the one that I showed you before. Those are the longitude and latitude, and this is the distance. Of course, if I increase the distance as before, we obtain many more. This is a JSON response, but we can configure and return also an XML example. This is the answer in an XML format for the same statement. And once again, if I change the distance, we retrieve more museums.
And this really nicely shows how you kind of expose a domain-specific API or protocol with the Neo4j server extension. So you don't send all the nodes and all the relationships and all the data you have out, but you kind of render it in a way that your client application can use directly and consume directly without wasting resources in general. The integration between Spring Data Neo4j and Jersey was a bit tricky to build, so it's coming out of the box with Spring Data Neo4j, and that's why this kind of Spring plugin initializer allows you to expose Spring beans as Jersey injectables, more or less. So in your Jersey resource, you just can do add context, and then it injects the Spring beans into your GOGH'S resource. So that's why we have this this plugin initializer there. At the end, I want to talk a bit about kind of the next steps where we want to go with Spring Data Neo4j. And we have two main developments. So we have a lot of people, a lot of large customers that use Spring Data Neo4j and Neo4j and also want us to push much more effort into it and keep it up to date and make it faster and so on. And so we decided to kind of do two things. So first of all, we want to keep Spring Data Neo4j 3.x working on maintaining it. So we will update Neo4j versions, fix bugs, resolve issues, and so on. But what we also want to do is we want to build a new version of Spring Data Neo4j. And this new version of Spring Data Neo4j has a bit different architecture than the existing one, because the existing one, as I mentioned in the beginning, was built around the embedded Neo4j APIs, so the in-memory Java APIs. And the new one will be built on top of CYPHER. So it's more like a traditional ORM that generates query that does send to the database, but which will allow us to have the same performance for embedded use and for remote use, because you push the work into the database and not have a lot of chatty conversations over the wire for each kind of piece of information that you want to pull. And so we can run it embedded and remote. And we want to use CYPHER actually, because if you look at what you can do with it, then you can even encapsulate or write a complex CRUD operation, a complex update operation in a few lines, 2 or 3 lines of CYPHER code or so, which allows us to have an object graph mapper that is much less chatty than traditional SQL-based ORMs. And the other thing that I think is really important nowadays is not just to focus on something like cascading loading, where you have a session and then you load stuff and then you get persistence exceptions because the transaction is already closed and stuff like that. But I want to be able to write a CYPHER query or have a derived finder method that kind of encapsulates or contains a complex business operation concisely, and then rather map the result objects back into my domain entities so that I can use them with other libraries, with web frameworks, and so on. And what also changes is transaction handling. Right now, Neo4j exposes GTA as a transaction infrastructure, but we deleted that from Neo4j in version 2.2 because we want to have we want to have fewer bottlenecks in terms of the database, and GTA was one of the major bottlenecks as well. And instead, we offer our own transaction infrastructure, which is exposed over the wire with a custom HTTP endpoint. And so it will be a three-level architecture, more or less. On the bottom, we have the JDBC driver, Neo4j JDBC driver, which is already available now, so you can already use it. It provides CYPHER integration with the embedded database, with in-memory databases, and the remote database. It provides transactions with embedded and remote databases. So that's kind of already a really convenient way to build simple applications with Neo4j. And then what we want to build is an Java-based, plain Java object graph mapping library, because many people also want to use Neo4j with object graph mapping from other languages, with other frameworks, and so on, and don't want to get the Spring dependencies necessarily. And then have Spring Data Neo4j on top of that, configuring this OGM and using this object graph mapper to do the actual work. And then Spring Data Neo4j will add all the conveniences that you already know right now, like repositories, lifecycle support, simple configuration, integration with Spring Data REST, with Spring Boot, and all the other things. So it kind of, the core of Spring Data Neo4j will be pulled out into a separate object graph mapping library, which is Java only, more or less. And then Spring Data Neo4j sits on top of that and uses it as a library, more or less. And so the different mapping modes will go away because there will be no embedded Java APIs anymore. And we can integrate with all the Spring infrastructure that's available, like conversion services, lifecycles, and so on. Exactly. So I already mentioned all of this, and for me, the biggest benefit is that the code base will get much simpler, because right now, over 4 years, it accumulated a lot of stuff, and people are already oftentimes really reluctant to let go. So when you want to kind of delete certain functionality or certain stuff, then a number of people say, no, we still keep that, and we still need that. But if you do a rewrite of the core, then you can easily just delete everything and then kind of add again, so you get a much cleaner code base as well. And something that we didn't have right now is transactions over the wire, because the old Neo4j REST APIs didn't support cross-request transactions, which the new ones with CYPHER actually do. And it will look more or less like that. We have Neo4j, either embedded or server. We have the JDBC driver running against Neo4j, which you also can use standalone. We have the pure Java object graph mapping, which you can also use standalone. But if you want to have all the conveniences and all the Spring Data benefits, then you use Spring Data Neo4j that integrates with these. So that's the plan, at least. And we hope to get it done by the next Spring 1, but hopefully much earlier. OK.
Before moving to the question and answer session, let me just show you the same application deployed on the Cloud Foundry. As you can see here, we have just now deployed the application, which is up and running, and we can exactly like the local version embedded. Now we are inquiring a web application which is deployed in the Cloud Foundry, and the database is hosted on GrapheneDB. More or less the same.
Yeah, and so the way how you integrate external services with Cloud Foundry is you use user-provided services in CF to integrate those. And exactly. So now we have some time for questions. we brought some books, and the people asking questions and asking the best questions will get a book. Something I quickly want to show, if Lorenzo lets me, is the Neo4j browser. I hope I can get it working.
Is what I wanted to try.
Is
just close
this one?
All? Reopen.
You can. Because it's really cool and it's a really nice showcase. So we actually want to show you how you interact with Neo4j usually, and let's see if this works.
Maybe it's only because it's. Try again.
I think it's JavaScript thingy.
Okay,
there you.
It's the dimension.
Let's see. Okay. So what you can do in Neo4j's browser is, first of all, you can create a database. So you can run CYPHER queries against the database. A simple query could be something like what Lorenzo showed. We are looking up a node by name and return this node. You can also say, for instance, we don't want to have the whole node returned, but we just something like a simple property or a set of properties. If we have this, go away. Damn it. No, I want to get rid of this stuff. So it's an Italian keyboard, so bear with me. It's me as a German working on an Italian keyboard is fun. So if we do this, we can also see the query results as tabular results, and then here you can see that all the properties of the node are already returned. And of course, we can write more complex queries. We can also filter queries. So for instance, I could say where, for instance, first name artist dot first name starts with a W, and this is a regular expression, something like that, and I misspelled it somehow. Yeah. Oops. Let's see if I find the tilde again on the Italian keyboard. Control, Enter. What does it do? I hit wrong button. I hit the wrong. So it's the wrong tilde, I think. It's not my.
Don't know how.
Not a German tilde, probably, right? Okay, let's try that again. Okay, no. Something Italian. But we can, for instance, say where it's William, right?
Vincent.
Vincent. Oh, Vincent. Sorry. So, Willem. The second name is Willem, right? So, sorry. But of course, you can also run more complex queries like we've seen before. For instance, we've seen the artist and his and the movements he belongs to. So we see here's the movement he belongs to. His birth town and the town where he died. And if we can also kind of explore these nodes interactively. So if you click on these, then we can expand them one by one. And we can also say we want to configure these nodes. So to, for instance, to look different than this or something like that. So this is all possible, and I can store more queries as well. And interesting is when I have more complex queries that I want to run, like here the stages of Van Gogh's life. And actually, if I look at the query, it's not a lot of code, right? I just have the art movement. The artist belongs to an art movement, and he was in a city, and that's about it, right? So with a really bit of queryable example, like Lorenzo said, I can just take the patterns that I would usually draw on a whiteboard, put them in a text language as ASCII art, and then run the query. And what's cool about that is also that non-developers can easily read and write these queries as well. That was quite surprising for me when, after we developed the language, that actually it's not only focused on developers because we focused a lot on readability in CYPHER. So every non-developer who understands the domain is also able to first understand these queries and then secondly also to write these queries, which is really cool. And so we can, We also have a table for that. Let's see. If I go to the tabular view, it's I see the artist, stage, and city then. But I also could just return something like city.name, comma, city.country, and art movement dot name or something like that, right? And if I run this, then I see also the tabular results as something like that. And this is also what enabled us to do the JDBC driver, because you can treat Cypher just as parameterized strings that you can send to the server. So you can use plug-in prepared statements and also use parameters within Cypher, and you get tabular results back. So you can kind of use the SQL APIs to talk to a graph database. Also, some of the stuff is, of course, not supported, like table metadata, because there are no tables, right? But in general, it's a really convenient way also to interact within tools. So I can take any kind of database tool, add a Neo4j JDBC driver, and then talk to Neo4j, which is really cool. For instance, in an IDE that has database tool support, I can just add it and then run my queries as part of my IDE. Or in ETL or BI tools that talk to databases, just use it like that, and then it's really easy to use the graph data to interact with that. In Spring, it's more or less, I don't know, do you have code for the import here? No. It's more or less, so actually I have an example for that. Let me just show it for you here. What you more or less do is you create your Spring Data Neo4j entities, and then you do a repository.save or template.save on the entities. There's no session, no. It uses, so you can use a transactional on the method, so then you have transaction scope. Let's see, as the end with, so there was an application that Josh Long and I worked on when I was in San Francisco presenting at Pivotal. And this is a Twitter application which uses Spring Social to do Twitter queries. And I have a service here which does the actual import of the data. And the input looks like this. I import the tweets, I execute a search, and then the actual input looks like this. So I create a user, I do user repository.save, I create a tweet, called tweet.save, and then I add the relationship to mentions and other tags, for instance, and I also just save these entities. And this creates not just the entities, but also the relationships between them. So when I look at the database later on, I have all the tweets with all the posters to say, so all the mentions, all the URLs, all the hashtags as part of my graph. So it's really just using the repositories or the template to save your entities, and then they end up in a graph. You can also use CYPHER directly to load data. There's a new command that's called load CSV, where you can just take an arbitrary CSV file, a dump from a database or something else. And then you take the kind of CSV line and get it as input, and then you say, for this element of the CSV line, I create a node. For this element, I create a relationship. And then you can kind of take an arbitrary complex dump of a database, which is, can be a join of 5 or 10 tables. And you create a graph out of that, where you, from one line of CSV, you create like 10 or 15 elements or so. And when you imported them all, then you have like 1 million or 10 million elements in your graph. And the last way of doing that, sorry, I'm almost there, is that, for instance, if you query a JSON API or so, then you can just grab the JavaScript object and stuck it as parameter into Cypher, and then kind of use Cypher to deconstruct the JSON and create the entities from that. So that's kind of 3 ways on how to input data. Yeah?
I see Neo4j is a first-class form,
yeah.
Can you speak to that at all? Same capabilities?
Actually, it's further than that. So a colleague of mine works on the Grails GOM plugin. And he actually already took the step that we still want to take. So his first version was like Spring Data Neo4j, working with Neo4j embedded APIs. But the current version of the GOM plugin already uses the Neo4j JDBC driver and the GOM infrastructure to generate the Cypher queries to talk to Neo4j. So he's already there where we want to be. So it's a full-fledged GOM plugin that supports all the GOGH'S features, also transactions over the wire via the JDBC driver. So it uses more or less data source transaction manager for that. And so it's pretty, I want to recommend to use that, and it's a really good thing. Yeah. So the question is how, after we insert the data with the batch inserter, how can we create indexes? It's pretty simple. You start your database and say create index on label and property, and then database will create the index. Or in the batch inserter, you can also say create deferred index, and then it creates an index on shutdown as well. The question is, can we also use Neo4j browser for the embedded version? So what you can do is something that people use for testing, more or less. It's not recommended to do this in production, is to wrap an embedded Neo4j database, or wrap the Neo4j server programmatically around the Neo4j database. And then the embedded database will be exposed with the same browser UI as the server as well. So it's kind of 5 lines of code. Yeah. Sorry? I haven't, unfortunately. But it, I think like Spring Data REST, it should build easily on top of Spring Data Neo4j. At least Spring Data REST works out of the box with Spring Data Neo4j. So for instance, in the Twitter example, I just had, let's see. I just have a repository REST configuration here, which I needed because I had a different, where did I put it, actually? Because I had a different base URL that I wanted to do, and that's it. So, but in general, it's, oops. In general, it's just an annotation away to expose. So all the Spring Data Neo4j objects can be exposed via Spring Data REST at least. So Spring Data headers should be no problem to use on top of that. Yes?
The CYPHER over REST, have you used that? Did you see any degradation of performance?
So it depends on what kind of queries you want to run. So CYPHER is fast enough for like 80% of the use cases, but there are some use cases where I would also use like a server extension for Neo4j to implement those, which are either kind of traversal heavy use cases that pull in like tens of millions of nodes in a single request or something like that. Yeah, so in, first of all, I would want to have a look at the CYPHER statement net flow. Oftentimes it's just like a simple restructuring of the statement that makes it fast. But in the cases where you really have kind of like millisecond requirements, SLAs, and your queries are not fast enough, then a server extension makes it easy to convert this CYPHER statement into a Java implementation. From my colleague Max DeMarcy actually wrote a blog post on how to convert a CYPHER statement into a Java unmanaged extension, if you want to do that. But also the CYPHER team currently works on a new query planner and a new query engine, which then will make CYPHER much, much faster because the current query planner is a bit simplistic, and the new query planner will take database statistics into account and is much more sophisticated in terms of how it will run queries. You can even use it already in Neo4j 2.1. If you prefix your CYPHER query with CYPHER 2.1.experimental, then it uses the new query planner. So you might try this first. And then perhaps you can also ask on Stack Overflow or on the Google group if you want to have any help with a certain CYPHER query or so. OK, yeah? Yes, I don't know if you've seen that in Lorenzo's repository. He also showed that he used add transactional in the on the repository, but you can also put it on the methods, or you can just use add transactional on your service or component methods as well. Yes?
I saw that in your code examples, you have referred to some indexes. So you have to create your indexes, and then what if I didn't refer to
Yeah, so the question was, we have referred to some indexes in our examples. That's because in Neo4j we're kind of in a transitional period right now, where we had, before Neo4j 2.0 we had all manual indexes that had to be managed manually. You had to add data to the indexes and then you could use these indexes. With Neo4j 2, we moved to automatic indexes for a certain part of the operation. So every exact lookup information is operation is automatically handled by an index. You don't have to refer to an index anymore. But for some operations, like for instance the spatial operations, you still have to provide kind of the old way of providing an index name. But currently we're working also on integrating other types of indexes like spatial, full text, and so on into this kind of automatic no-fuss implementation of the index API. So that with one of the next versions of Neo4j, you won't have to refer to any indexes anymore.
So follow up on that, just like if we were running into performance issues typically in an RDBMS, we would even explain to see exactly what happened. Is there something similar?
There's something similar in CYPHER. So you can, there's a profile keyword that you can prefix the CYPHER query with, and then it shows you the query plan that it uses to generate your query. So for instance, if I, let's see, we don't have that much time left, but if I put profile here, it's not yet in this UI, but we have the, oops, sorry. The Neo4j shell UI, where is it? Come on. That you can use profile with, and here, if I run this query, then it shows you how it actually. This is an older version of Neo4j, right? So the 2.1.2 or so has a more tabular way of showing the explain plan. And actually, in the current version of Neo4j 2.2, they added an explain verb, which gives you also a better representation in the new UI. But with profile, you already see that, for instance, this uses the schema index automatically without us having to provide an index. And with this identifier, it shows you how many database hits it had, and then it also says what it returns and so on. So that's the first step of an explain, more or less. Yes?
So, in your example, like you have using an object. Those information is already existing in my transactional database, which is changing continuously. How do you keep Neo4j relations updated?
So the question is how to keep another database, like a relational database, and Neo4j in sync, correct?
Yeah, from another relational database to Neo4j.
Yeah, so there are several means of doing that. So either, so depending on how your architecture looks like. So some people have like an event source system, so they can write to two databases at once. Some using something like database triggers to trigger updates in another database. You could also, there's also some means in relation databases that you can trigger on the transaction logs on the relation database and send updates to another database. You could also pull regularly from the relational database. Doing things like that. It always depends on your kind of system architecture, how you already integrate different databases. And so if it was for me, I would go with an event source system and use something like that to kind of update many different read stores, for instance, for different use cases. But it always depends on the architecture that you already have. Some people also just use an ETL tool that they run continuously, or something like Spring Batch, which kind of pulls data from one database, converts it, and puts it into another. Okay. More questions?
Elements of the browser UI that are available for using in our application?
That's something we're currently working on. So the visualization component is to be open sourced in the next few weeks, which uses which uses D3 as visualization. But Neo4j is an open source database. I didn't mention that in the beginning. So Neo4j is open source. It's on GitHub. So you can also just go to GitHub, pull the data out of the browser directory, and it's written in CoffeeScript and AngularJS, and uses D3 for visualization. So you can just pull any component that you want to out of that and just use them out of the box. But it's also really easy to build something like this yourself. So there's a For instance, when I flew back from OSCON to Chicago, GitHub.io, site to Neo. I wrote a tiny browser shell that uses Alchemy.js, which is an open source graph library sitting on top of Neo4j, on top of these three, and which uses CodeMirror for the visualization. And here you can see I can just run queries against any database, visualize them, and make them available. So it's not rocket science to have something like that. Took me like an hour to build or so. So that's really easy going these days. OK, cool. Thanks a lot for all your questions and your time. We really appreciate that. Those of you that asked 2 questions can come here and grab a book. Everyone else, you can also get the free PDF download of the book from the card that I put out. Otherwise, we have a booth. Oh, I forgot to mention that, right? We have a booth at the conference, and we if you want to learn more, we have a conference in San Francisco in October. Whoever is from the Bay Area, you're welcome to come. We have a massive discount code also at the booth. And otherwise, come join us on a Google group, wherever. We're happy to answer your questions and help you be successful with Neo4j. Thank you.
Thank you so much.